Good morning, everyone. My name is Jason Robinson, and I'm going to give you a little introduction to our Greece GeoStreamer program. We have some fast-track results, so we can generate some interest in preparation for the license round next year. So here's a brief overview of the talk. I'm going to give you an explanation of the location, a regional geological overview, with and then a description of some of the basins and plays that we're going to be talking about and looking for. And these can be split into three areas that I'll focus on with some examples of the seismic. The North Ionian, which consists of the Apulian Plateau, the pre-Apulian Foreland, and the Hellenite Thrust, Central Ionian, and then south of Crete. Here's an image of a map of the program itself. It extends from the Albanian-Italian border all the way around to the south of Greece to the easternmost extent of Crete. It's a regional program for general exploration purposes. In the north of the Northern Ionian Sea, we have a 10 by 10 kilometer grid of lines, and these extend out over the edge of the platform into the abyssal plain for some of these lines. To the south of Crete, we have a 20 by 40 kilometer grid, which is a more exploration, more sparse grid. And then there's an arrangement of lines in between to image the deeper waters. It's a sparser grid. And then some lines in around the existing discoveries, and we have a lot of legacy data in here for infill as well. It's in preparation for a license round in 2014. There was definitely a new data requirement. The legacy data is from the late 70s and early 80s. We acquired seismic and gravity and magnetics data. It's available on a multi-client basis, and it exists of 12,500 kilometers of new data. There were two acquisition parameters used. Everything was recorded with a 10 kilometer streamer and using geosource. The lines in black were recorded with a 25 meter source interval to improve the inline sampling, and a 10-second record length. The lines in red were recorded with a 37.5 meter source interval and a 14-second record length to image deeper, image the basement, and if possible down to the crust, down through the crust of the moho. Here's the details of the acquisition parameters. So the source was either 25 or 37.5, and it was a geosource, so it was recorded, it was generated at 9 and 5 meter depths. So the data that's available now is indicated on the left here. It's the fast track, lines in red. So it's a subset of the data that we've accelerated through the processing in order to get an early view of what's there and get geologic input from interpreters so that we can have a geologically guided processing flow. On the right-hand side is a map of the existing data, legacy data, and the vintage of this is colored, and it runs from 1975 through 1985, and then some more recent 2000 data. It's all very short offset, short recording length, and most of it, as you can see, is imaged close to the coast in waters that could have been drilled at the time. It's a variable quality and variable source type as well. We're reprocessing about 6,000 kilometers of this initially, and that is to tie our new data into the coast and to tie it to wells, and for imaging in these shallow water areas where we weren't able to operate for environmental and practical reasons because of the streamer length. The fast-track processing flow is to remove the ghost with the GeoStreamer and GS processing, and then to run multiple removal, and then 1 kilometer Vorsi analysis for pre-stack Kirchhoff, and then apply Q compensation. So here's a little overview of the geologic setting. The Hellenide and Greek alpine activity has been pushing down to the southwest, and the speculated oceanic crust has been subducted underneath this as a result of this collision, this interaction. The current coastline represents the major uplifted inverted Hellenide activity. So it's a combination of the Ionian and the pre-Apulian, and then further to the east is the Gavra and Pindus. And the geologic domains that are represented in the offshore in this area are the Apulian platform, which extends up into the Adriatic and in Italy, and there are existing plays up here. On the margin of it, there's a shallow fallen basin, which is fairly narrow, down alongside Corfu, which runs along this red line here. And then on the other side of this is the shelfal area, narrow coastal area, which is the uplifted Hellenide and Ionian area, which is overthrust, thrust naps, and represents some potential. To the south of the Cephalonia fault, there's more of the pre-Apulian overthrust material, which extends out to this bathymetric contour, and similarly down to the south is overthrust material. Out in the Mediterranean itself, on the outboard side of the Hellenic Trench and the trench systems to the south of Crete, is a larger slab of continental crust which overlies the oceanic, and there are areas where there may be very good potential for thick sediment, but it's in very deep water. So in the North Ionian, I'm going to go through the North Ionian central area around Cephalonia, or south of Cephalonia, and then south of Crete. So this is the North Ionian area. The play types here are represented by the Apulian platform itself, Apulian ridge here, and northern, for example, has a couple of play models up here within the Apulian ridge itself. It's represented by Cretaceous to Eocene carbonates, and then overlain by more recent sediments, which could provide a good seal. Because of the tectonic regime, this is a flexed carbonate platform, and has a ridge that runs from south to north, and it dips down to the south towards the Cephalonia Wrench Fault. So there are plays in the actual Apulian ridge itself. On the margin of it is the fallen basin, which should have reworked carbonates down on the flank, and which is overlain by nicely stratified fleisch type sediments. And then close to the coast itself is the actual Hellenic thrust, which is represented by Paxi and Ionian sediments. So those will be different play type rather than stratigraphic and fault-controlled play types in the Apulian. These will be thrust, and if there's salt involved here, if it's present, could provide some plays up against the salt. So some examples. This line runs from the Preveza Bay area out across the Apulian platform onto the further out to the east. It drops down onto the Ionian. Here you can see on the north to the northeast side the Paxi, or pre-Apulian, which has been upthrust and overthrust and has these fold naps. And the plays, this is a early version of the fast track processing, so it will improve from this once we get the velocities and imaging correct. But we're getting very good resolution in the near surface, and we can pick these tops of what we believe are the carbonates on this unconformity. Off the edge of that margin, there's a small fallen basin, and then you can see the flexed Apulian platform out towards the southwest. This line is a little further north. Here you can see the fallen basin, which we'll zoom in on a moment, and the carbonate platform with its these north-south running, because of the nature of the compression, it has these north-south running faults and horse graben. So there's an extensional regime in the center of the platform, which is relief for the compression over to the east. 2 days. EAG will be over by then. So we're going to zoom in on the shallow area here in this section. This runs from about 1.5 seconds here down to the base of this basin is this fallen basin, and the unconformity is at 2.5 seconds. So we have a good stack of sediment, and it's in about 1,500 meters of water. Here we can see the top of the unconformity of the carbonates on the platform. So this is Eocene carbonates, and the play model in here is that it will be reworked carbonates that would have come down onto the margin and then been overlaid and sealed to form a good seal. This basin extends further to the south. It deepens and provides some good opportunities. Here we have a line running from north to south along the Apulian, the Adriatic, so the Apulian platform, and we can see some areas of also extension and sediments that have formed on top, and you can see it diving to deeper